All right. Let's see. Today we're going to do a little bit of G-code stuff. Plotting. We're going to work on our plotter here, or printer turned into a plotter. That's probably about all for today. Next week, I think I'm going to try and do the Palette 2 Pro. I think it actually is a Palette 2 Pro. This is a device that takes 4 different filaments in and joins them into one continuous string. So it cuts them and melts them together into one continuous filament. And then that filament feeds into your printer, and the pattern that the palette chops it in makes the outcoming filament, or outcoming print, to be multicolored, so 4 colors. Right now it's not working though, so it may not work next week and we'll do something else, but we can at least look at it and see kind of what it does. I don't know if I've shown it this quarter or not, but today we're just going to do the plotting. So first of all, what I've got here is, this is a different printer. So this is an Ender 3, but it has this little quick change deal on it. This, let's see if I can get a better view of that. There, it kind of is there. So it mounts in place of, well, between the old extruder. So here's the extruder the way it normally is, right there, and it's got this little cam lever, and now I can go back to printing, or I can take this out, and I've got a little holder up here for it so it's out of the way, and then we can put this little guy. It's gonna hold our pen. I'm using this kind of what is it, Papermate flare pen. I have a couple of other attachments that can go in here, and basically it's an easy way to change out different things. You can do this, this particular one. It is it's on Thingiverse. Let's see if I go to Thingiverse, if I can. Actually, I have it. No, I don't have it pulled up. I think I might have put it in the chat, or not the chat, but the links for everything. I'll do it right now. Let's see. If you search for Ender 3 Quick Change, it should show up. Let's show you what I'm looking at. This is it right here. So there's a laser mount. Well, let's click on it so you can see it larger. There's a laser mount, so you could do not a lot of laser cutting. I guess you could cut paper, things like that, but more laser etching type stuff. You can do that. This is a little couple of watt laser. There they've got a Dremel-like tool, rotary tool. Here they've got the regular hot end. I made one. I don't think this one has in it a pen holder. Oh yeah, it does. Or no, that's the Dremel tool. But in here, one of these was a blank. Well, I don't see it now. I thought one of them was a blank little inset. Maybe I just chopped off one of them and put a pen holder on it in like Tinkercad or something. Anyway, this thing is what I printed and what I use for that. I'll put it in the chat. There we go. If anybody's interested in printing one of their own. But you don't have to do that. You could just tape the pen all onto the side of the extruder, and that would work. It's a little difficult because you have to move, you have to home everything with the pen there. So there are a lot of these pen mounts that are like this kind. Actually, there's only one like this kind, but there are a lot that you don't have to remove the hot end assembly to be able to do this. It kind of just bolts onto the side or tapes onto the side or whatever. There's some really fancy ones that are kind of spring-loaded so that you don't have to try and get the height just right. You can have it pressed down. That's one of the reasons I'm using a felt tip pen, is that it, or something like a felt tip pen anyway, is that it can press a little bit, and this printer doesn't have the solid mounted bed, so it gives a little bit more than the other printers would. All those are things you have to think about to get this to work. This printer doesn't have a BL Touch on it. Keeps focusing weird every time I touch it. There we go. It doesn't have a BL Touch anywhere. It did, but it would come off with the extruder even if it was on there. So you have to level everything pretty well. And I've got a piece of glass under here to kind of even out any undulations in the bed surface. So all of that to get it flat, and then you can use it like a plotter. So first, let's show how you might do this. First, let's get rid of this one. So I've just got binder clips. The binder clips are actually holding the glass on, but they're also holding the paper on. So let's get them off of here. Oh, one other thing. This printer does have the SKR 32-bit board on it, but I'm running the touchscreen in the old LCD mode, so that I have a message that pops up when it tells me to set the pin in place, and that doesn't show up on the touchscreen, but it shows up on the LCD mode. So I'm in LCD mode. Get a sheet of paper. Let's see if I can get it clamped in there. And then we got a little bit extra here. Let's cut that off, just so it's not in the way. There. You want the paper to be relatively tight, because since you are pressing straight down on it, it can bunch up, and we'll get that ready in a minute. All right, so here's what we do in Cura. So I'm just going to use Cura to create our picture. So here it is already done. Let's get it back to this point. So because there's a couple of steps that make this work after, or that we need to do before actually going in and just throwing it on the printer and trying to print it. So let's get rid of this. There were errors in that model. That's okay. All right, so first of all, I went over here. I'm in Cura. What am I version? Let's see. This is version 4.8. So I think that's the most current one at this time. So over here, I went in and I added a printer, and I added this printer. I called it Plotter. So here's the others that are in here. I added a new one. So let's go to manage that one. Oh, it's popping up over here. So this printer called Plotter. Actually, let's add a new one so you can see from the beginning. It pops up on the other screen. Here we go. It's a non-networked printer, so I don't have it connected to the network in any way. It is a Ender 3, so we can start with that. Reality Ender 3, just so we have the right E-step. Well, E-steps don't matter, but the X and Y steps and the Z steps, and the right bed size and stuff like that. So we can start with the printer that we do base this on. So we'll add that. So that way all of these sizes are already filled in. It is a rectangular bed. The origin is not at the center. We're going to uncheck heated bed because we don't need to heat the bed while we draw on it. G-code flavor, we're going to use Marlin. We'll leave these the same. All of that's the same. Let's change our start and end code. Actually, let's just look at what since I've already changed it, let's look at the one I did change. All right, let's, can we delete this one? Remove that one, just so we don't have it in there. Yes. All right, so let's look at the G-code I did add here. Oh, I need to switch over to it. Activate. Machine settings. All right, so here's the G-code that I added. I completely erased all the old G-code. So that, because a lot of it was about heating and things like that we didn't need. So here's what we do have. And we'll go into some G-code descriptions. I guess we'll kind of do some of them right now. But G21, just so that we know we're in metric. That's kind of the default anyway, but it's good to put it just to make sure that you're not sending data in inches and it's assuming metric or whatever, so, or vice versa. So G21 sends it to make sure it's sending metric values. G90, that's absolute positioning. So what that means is, are the coordinates that you're telling it to go to, are they relative to where it currently is, or are they absolute coordinates? And most of the time, you want it to be absolute. There are times where you might want to do a relative movement, say to lift the Z a certain height above where it currently is. And so it doesn't matter where it currently is. You switch over to relative and just tell it to go 10 millimeters higher. And then switch back to absolute mode after that, so you can lift it up or whatever. But most of the time, you're going to be in absolute, so that you can tell it to go to a specific point on the bed. So that's G90. We don't need the fan, the layer cooling fan, so we can turn that off. And then here is the homing routine. Now this, we could do X, Y, and Z all together. In fact, we could take all of these lines, G28 with all of the things after the semicolon are just comments. We could just replace all of that with G28. That's home all. Whoops. Got a really long line there. Let's see if I can get back to the beginning without it scrolling off the screen. There we go. We do not want to recalibrate Z. I actually had this in there, but this would be the BO Touch probing the bed. We don't want that. Here, this is after it homes everything. So it's homes X, Y, and Z. And now it knows, and it's probably sitting in the bottom left corner. Should be anyway. And now we're going to send it over to 2525Z0. So this will send kind of over to here. Well, off the screen. Over here. Somewhere in here. 25 in the X direction, 25 in the Y direction, and Z equals 0. Now at this time I don't have the pin in. I wouldn't have the pin in yet. The way I'm going to do it anyway. So this would just be sitting more or less, I don't know, right here. And that's the point where, let's see, at that point, I do this M300 and S440, P500. What that does is it plays a 440 hertz sound, so an A, concert A, for half a second. And it just is a warning on the, that it's ready. And the next thing it does is M0, which is pause, or at least wait until you click the button on the LCD. So we click this button, and this is where I wanted the LCD screen, because it's also going to push, or not, well, it's going to print on the screen, adjust the pin, then click. And it's going to say those words on the thing here after making that sound. So that's when you put the pin in, get it to where it's the right height, click this, and it'll carry on at that point. So the M0 does that. The M0 is pause and wait for a click, basically. And actually that's what all of this that's making it go off the screen is saying. We'll move that out of the way. And then what it does is it basically just goes back to 0, 0, Z15. So it goes to the corner and raises up the Z height a little bit from that point. So at that point, all of this is the start G code that's going to get pasted in front of whatever slicing G code you have. So it does all of this at the beginning, and then there's some shutdown. A lot of these don't even matter. Actually, some of these I think might have been left over. Maybe I didn't erase all of these in G codes, but basically you just send it back to 0, 0, and turn everything off. Turn the steppers off. Do the little presentation where it moves the bed out in front so you can get to the piece of paper. But most of all this in G code doesn't actually matter. Like the fan's not on, the hot end's not on, the bed's not on. So all of those are just there because they're always there in the in code, but they're not doing anything here. G1, X0, Y. Now machine depth, you notice this one's different. This machine depth in curly braces, that's a variable. So there are some variables you can use that are built into the values of some of these, like your temperatures can be done as variables. Some of these depths, so like this value right here is, if I hover over it, it might actually say that it's machine depth. No, it doesn't. But you don't necessarily know what the variable names are. But there are some variable names where here, instead of doing a Y235, now the problem is, and I remember this now, 235 is actually a little bit large for the ender bed. So I'm going to actually go and put in a hard-coded 200. So it'll come close to the front, but not all the way to the front, because it bangs on the end stop up here, or not the end stop, but the end of the rail. All right, so there's that relative positioning mode that I was talking about, where instead of just moving to a specific point, it moves to a relative position from where it currently is. So it just moves up 15 millimeters. It moves the pin up. A lot of times it talks about the bed moving. So in this case, the bed moves down, although the bed doesn't actually move. This refers to some of the older original printers of this style. The bed was what moved up and down. And they still have printers like that. And there are reasons to have that kind of printer, but a lot of times you'll see references to the bed moving up and down, even on these printers where the bed doesn't move up and down, it moves in and out. So here, there's a home, so it's going to home X and Y. This one is different from the G28 home all. When you leave no parameters on it, it's home everything, X, Y, and Z. Or you can tell it specific things to home, just X and Y, but not Z. Then it turns the stepper motors off so that if you wanted to, you can move things around by hand. Then it goes back to the absolute positioning mode. It only needed that G91 for this one line, actually. The home all doesn't care about relative or absolute. It's looking for the end stops. And then there's the present print, so it moves the bed out to the front. These aren't doing anything. And then we don't even need that line. We already disabled the steppers. We might actually do this line instead of steppers off, so that the Z-axis, remember, it's sort of easy to slide up and down if you push on it too much. So we might actually change this out. And let's just erase these, because these aren't doing anything. So we'll keep the Z, so it's going to disable X, Y, and the extruder, although that's not doing anything for us. And then it'll keep the Z so that the pin doesn't accidentally fall onto our printed bed, our printed picture. All right, so those are the setups that we can have for creating a new printer. So that this way I have a new printer set up, and I called it Plotter, so that I don't have to go do this stuff every time. I don't think we need to change anything here. We're not actually extruding filament. In fact, you should take the filament out of the hot end, because we're not actually going to heat the hot end, but we are going to do some of the retraction settings so that we can Z-hop, so that the pin doesn't drag across the drawing as it's moving from one spot to another. We want Z-hop to be on, and that requires retraction, which we aren't actually going to be retracting any filament. So you need to remove the filament from the hot end. All right, so this will work. There are still some settings we need to work on over here, though. So not all of these may be active. I might have added some of these, but the initial layer height, we'll leave that at 0.2 for now, but we may change that when we slice it to get it to only draw one layer. Layer speeds are fine. Material, I don't have anything. Oh, here's the problem. I've got build plate searched. All right, there we go. Oh, you can actually see the ones that I've changed. I changed wall thickness to 0.2, although you can change that to any number, really. It's kind of going to decide how thick the walls are, so it's going to, when it slices it, it's going to decide if that's going to be drawn or not, basically, or if it's going to be drawn with one line or two lines. We put one parameter on here. The top and bottom thickness, this one is what I'm going to use to modify so that I only get one layer sliced. You'll see in a minute. top layers of 1, bottom layers of 0. The way I'm going to do this, we're actually going to use a bitmap as our object we're going to slice. If you haven't noticed, when you go to open files, you can open all sorts of files, JPEGs and bitmaps and regular 3D printing files. I guess PNG. I don't see that in here, but bitmaps and JPEGs. We're going to use a PNG, so it must be in here or just not listed. Huh. I don't actually see it, but it worked. So we did use a PNG because there's the file. All right, close that for now. Infill density, this one basically will decide how much cross-hatching it's going to do. I have it at 20, but you can use, in this particular one that we're doing doesn't have a lot of areas that are going to need cross-hatching anyway. It's all basically just lines. It does a little bit, but not a lot. And then you can pick what pattern you want. Maybe we'll use grid. Make sure the printing temperature is at 0. We don't want any heated hot end. For one thing, it'll just cost extra time waiting for it to heat up. Plus, that hot end, if you don't move it somewhere, then it is sitting really close to the print and the pen, so that's probably not a good idea. So turn that to 0. You can probably print a lot faster than normal, but I left it at the normal print speeds. And then here, you want to enable retraction. The actual distances don't matter. What you are really after is Z-hop. So Z-hop may not be a default. If it's not, then you need to go into this little gear icon and select Z-hop when retracted, and also the Z-hop height, so that how high it lifts up. So where were we? Retraction minimum travel. So this, I made a really small number. What this is how much line does it have to draw before it is going to Z-hop. So I made it really small, so it'll draw even little dots with that width and still Z-hop after them. If you don't have this at a small value, it might have some little dots in it, and it doesn't Z-hop after them, and so it's going to draw a dot and then drag the pen to the new place, not going to hop or lift it up. So you want this to be a really small number. 0, 1 seem to work fine for this drawing. Combing mode is also, all of these italic ones are ones that aren't on by default. So combing mode, it is controlling where the nozzle is going to be, kind of keeping it in already printed areas when it's moving around as much as possible, so that it's not dragging the pen across places that you don't want it to work. This will also help if you're having stringing problems. This might help with stringing a little bit, but I set it to all. And then here's the Z-hop when retracted. I have it hopping 3 millimeters. That was quite a bit, but it worked fine. It kind of depends on if you're using one of the springy setups or a hard mount like this one. I could probably drop mine down to maybe even 1 millimeter. I'll do 2, just to have it a tiny bit faster. This picture that we're going to draw only took us, I think it took like 3.5 minutes to draw it. We don't need print cooling because we're not even heating anything. We don't need support. We don't need any build plate adhesion, so skirt brim. Well, you could have those if you wanted to have an outline around it, I suppose. That might look kind of neat. And it would give you a little bit of time to adjust things if you needed to, but I just put none on there. And those are all the settings. So the settings you really need to change are the Z-hop under retraction. If you don't change that, then it's going to drag the pen across your drawing and kind of scribble on it while it's moving from place to place. Print speed, you can change to whatever you want. Definitely have the printing temperature off. The build plate, we didn't, when we set up this plotter, we told it didn't even have a heated bed, so it doesn't even give us the option to set those temperatures. Infill is more of a thing to play around with. And then here are slicer settings on the thickness. Those we kind of have to modify once we get the picture in here. So let's open the picture. I'm going to open, and I just found this. I typed in, I don't remember what I typed in, but something along the lines of line art drawings into Google, and somehow saw Iron Man, and it's a PNG, and that's what we're going to do. So we're going to open that. And this window pops up in Cura. So this is how Cura will handle this. Other slicers, I don't really know how they'll handle it. And so you could actually print this. So let me just bring it in with the regular deals. And it actually brings it in as an object that you could print if you wanted to. Now it says it's non-manifold, meaning there's gaps in it. But let's bring it in. So I did set this base to 0. If you wanted to print it, you would probably want, like maybe a lithophane, you would probably want some amount of base to print. So it's not just lines on the paper, filament lines on the print bed. But I didn't want a base, so I set it to 0. The width and depth, those are basically how big is the print going to be. I don't think they are, let's see, this is 120. Oh, they do. Okay, they are scaled to each other. So if you want to make it larger or smaller, it will automatically adjust the two so that they're in the same ratio, aspect ratio. The height, this one I set to 0.4 millimeters, but you know that one you have to try and a couple of times to see what is going to work. If you set it to 0.2, here's what will happen. Down here, smoothing is just how smooth is it going to try and taper off these lines. It's actually on really low. We'll do linear, darker, so the black lines will be higher. If I do 0.2, see, I don't get quite as many lines to slice. So that's why I extruded it up a little bit higher than that. So let's send it back to 0.4. All right, and I get a few more of the lines poking up. So apparently the image that I used is more grayscale than in pure black and white. And so some of the black lines are a little bit blacker than the others or darker than the others. And remember that it has one of the options as the darker is higher, meaning a black line will raise up the print. Or you can do the inverse of that, but in our case, that wouldn't really make sense here. All right, I don't need another one of those. So this is what you get under those settings, and then you slice it. So let's just slice. And you definitely want to preview this to see what you're going to get. So there's what we're going to get. And you can see, ooh, you know, it's got a little bit of infill here, a little bit there, some walls, and the most important, well, not the most important part, a important part is that there's only one layer here. And that's because of, I think the one that most controls that is this thickness here. And it will, like if I set this to 0.4 and slice, well, even that works fine. Let's do it as another one. Let's see. It is possible to get some combination. Well, these are all doing one layer thick. So it is possible to get a combination that will stack layers on top of one another. I don't think, actually this one might have right there. Can't tell. It's very flat, so it's hard to tell. I think these are on top of those others down there, which since we're drawing, it doesn't actually matter because it's just going to draw it on the same plane. But if it moves the pen up and tries to draw, then that is a problem because it's floating above the paper. So I'm going to go back to my 0 point. I was at 8, I think. It still looks like those are on top of the others. Maybe they're just overlapping. I don't know. But you don't want it to actually have layer on top of layer because if it moves the pen up, then it's not in contact with the paper. All right. So let's save this. Actually, let's get our SD card. Here it is. All right. Save to file. And is that the right? Yeah, that's the right one. Let's make this Demo Iron Man. Now, let's actually look at this in Notepad. All right, so let's make sure it didn't do any odd things. Well, so it did a little bit. Here, this is trying to set the extruder temperature, but it's setting it to 0. So I don't know what would actually happen here. I'm just going to erase this line so that we don't have to worry about what will happen. And then the rest of this M105, I'm actually not even sure what M105 does. Let me see. 105. Oh, that's send. Oh yeah. That sends the temperature to the screen. We don't need that. So it just sends the value of the hot temperatures to the screen on the LCD. So we can get rid of that. Well, might not hurt to have that just to see it. All of these are just comments, so we don't need to worry about that. And then there's the stuff that we wrote. Well, I don't know if we wrote the M82, but we wrote the others. We might have written that. And then it starts going in with the, all of the movement commands. Now it's actually, these E's, those are extrusion lengths. So it can't figure this out without extruding, figuring out how to extrude material, although it's not even extruding. Although I guess we could look at the bottom and see how much ink we used. So we used 168.5 millimeters of ink. So we could actually try and calculate the volume of ink, I suppose, if we wanted to. All right. Oh, I did change one other thing now that I think about it. Let's see. In the nozzle. Well, in the line width, I guess. I did set the line width to 1 millimeter, and that will also affect the slicing. It'll just affect what lines it slices. Basically, you want to set this to somewhere near the size of your nib on your pen. So this pen does not have a 1 millimeter nib, but I put it at 1 millimeter. If you make it a little bit smaller, then it might draw one line twice, depending on how it interprets it. It won't be a big problem, but this line width will affect the slicing. I forgot that I changed that until I saw it in the thing there. All right, let's get our deal out here, and let's go over here. Oh, put this one in. All right, let's get where we can see everything. Now I don't have the pen in yet because it's going to tell me. We wrote that what command is that? M30? I've already forgotten. Let's see. No, the M0. We wrote the M0 command, which is going to pause for us. So here I'm just selecting the, I may have to reboot it. There it goes. We called this Demo Iron Man. There it is. All right, so it's immediately going to go into all of the routine because it doesn't need to heat up anything. So there, now it says over here, you can't see it, but it says adjust pin. So let's get our pin in there. And I'm noticing that I'm going to need to actually move that over. It is over the bed, but it's just barely. I think that's probably good. Now it moves it out of the way, up, and then it starts drawing. I can't fast forward here. You can fast forward if you're watching this later, but, well, we could fast forward. We could make it print at a faster speed. Now notice it did kind of draw that line a little bit light. We could give this an extra little twist to get a little more pressure on the nib. So it's a pretty cool little process. You don't have to print all of this stuff. This just makes it simple to change it in and out. The ones that are spring-loaded do work a little bit better, so that there's always a constant pressure on the between the pen and the paper. This one, I'm having to adjust it there a little bit because that line's a little light. The progress bar still works over here, so you can see we're about half done. Apparently that corner's a little bit higher, a little more draggy. About 3/4 of the way done. I'm pretty sure I made one of these an optional assignment if you wanted to do a plotter type thing. You don't. You'd be fine to just tape the pen onto the hot end and just be sure you turn the hot end off, and it should be fine. Almost finished. It's doing all the little dots. That's it. All right, so and then it does the homing thing, and then it does the present, bring the thing out to the front, and it released all the axes except for the Z, so that the pen doesn't accidentally fall down. You can take the pen out now, and it's pretty neat. I don't know if it's particularly useful, but it's an interesting thing to do nonetheless. Let's look quickly at just some basic G codes. Actually, why don't we take this out, put a new sheet in, and put the pen back in, and then we can do some G code printing manually. So the long way, just so we can see what the G codes are doing. Let's get that again. If you're doing this, your belt is right under there, so make sure you don't cut your belt out. That'd be kind of bad. Maybe you could pull it all the way forwards and do that. All right, so let's close down Cura, and let's connect to USB so we can send commands directly to the printer. And I'll use print run pronterface to do that. You can do that in Cura also, but you don't get as much. I don't know, it's just I like the other better if I can get it to plug in. Oh, I remember this one was always, it's right at the edge. It's hard to get it to plug in there, the way it fits. All right, let's go to here. Let's see if we can connect. Probably not COM1, probably COM 5. We do have to shut down Cura. I did. If you leave Cura running while you try to connect, the Cura is going to hog the USB or the COM port. All right, so we're connected. Printer is now online. All right, so over here, let's see if we can get this in the screen. Let's make it smaller. All right, That looks good. Except that, oh, it doesn't scale the whole window. All right, so we got to do it this way. All right, down in this little box, it went by the send commands. That is where we can send G-code commands. Let's move this out of the way because it's kind of distracting me. All right, so like we did in the beginning of our start G-code, I might as well cover this all up. Start G-code on the other one, the plotter. One of the first things you want to do is usually home. So we can actually go in and home all. So that would be G28 and send. Well, I'll send it back over here so you can actually see what happens. Now we just did G28. So that's going to home everything. X, Y, and Z. All right. Now I need to, let's put the pin back in. So I don't know how high to put the pin. So right now it's not over the bed. The pin holder is not over the bed. So let's move over. We're in, by default, we're in absolute positioning mode. So we don't, if you don't tell it anything, then that's the mode you're in. So if you wanted to make sure you're in absolute positioning mode, you could do G90. And that doesn't give you any effect. It doesn't look any different. Nothing changes, except that it's in absolute positioning mode now. To move from here to somewhere over, you know, it's in 0, 0 right now. So we want to move somewhere over here, maybe to set the pin height. So that looks like maybe, whoops, those are inches. 50 millimeters over and, I don't know, 30 millimeters up. So to do that, we would G, and then you have a choice of G1 and G0. So G1 is the regular movement speed, and G0 is fast movement speed. So we'll do G0. So we want to go to X of 50 and Y of, I said 30. And let's just do Z0, although it's already at Z0, so it won't actually change that. But let's make sure it's at Z equals 0. And then we'll, oh, I'll show you what I typed. I just typed this. G0, X50, oh, I left a space there. Y30, Z0. Now let's send that. Now we can put our pin back in. And it's at Z height of 0, so we should be able to, you know, get it there. Let's move it up. So let's, oh, I sent it again. Let's Z, we're at Z0, let's do the Z15. So now the pin is not sitting on there, it's 15 millimeters above the surface. All right. So that G, let's do G1. So the way these commands work, these G-code commands for G1 and G0, is when you're in absolute mode and in relative mode is different because it is moving to a position relative to where it currently is. So basically when you're in relative mode, it always assumes the current position is 0, 0, 0, the origin, and then you move from that point. Whereas G1, well, not G1, G90, the absolute mode, is going to a specific point on the bed. So wherever it's currently at, it's going to take a straight line. These are all straight lines. In fact, that does make me wonder if the curves are implemented. We'll try a curve in a minute. But this is going to go a straight line. So if I'm at 15 here above, so Z15, and I want to go to the middle, it's going to, you know, slowly taper down to wherever I send it to. If I wanted to draw a line from here, I've got to go back down to the bed and then go across. Because it's a straight line between the point you are and the point we put in here. So let's say that we want to, let's draw a line, a square in the middle of our bed. So to get it to go to the middle of the bed or near the middle of the bed, let's do G0 for the fast move. X, this bed is 230 by 230 or so. So let's do 115, Y 115. So 115. This should be the center of the bed. So let's send that. We didn't send it a Z command, so it should just go straight across there without drawing. All right, so that's more or less in the middle. Now let's go back over here. Let's say that we want it to drop down, so it's 15 above. So let's just go to Z0 from here. So I won't even show you that. It's just going to drop it down. Check our height. Our height looks good. Now these are ink pens, so you know the longer you leave them sitting there stationary, that's going to bleed some. That's just, we'll just have to deal with that. Now let's do G1. That's the slower speed. And let's go. We're at 115 in X. So let's go to X. Let's make it a I don't know, a 20 millimeter. So that's 135. So I'm only going to send it X 135. Everything else is going to stay the same. Oh, we didn't. We were too high above the bed. All right, so let's go back. I won't show you that one, but that's X 115. All right. Let's get this more like that. Now let's do, actually let's do more than 135. That wasn't much. Let's actually go to 110. There we go. Now we're at even numbers. It's easier to deal with for me in my mind. Let's go to 150. So this is going from 110 to 150. Should be 40 millimeters. Now it did, although now for some reason I'm having drawing troubles. Let's see if it actually went 40. It's pretty close to 40, almost exactly 40. Let's go up 40. So that would be G1. We're at Y 115. So Y 115 plus 40. Drawing a little better. And then let's go back to X. We were at 110, weren't we? 110. And then let's go back to Y 110. 115. We were at 115. And one thing you can check with this is it's easier to tell if things are square now. You know, it kind of looks, I don't know, I'd have to check with a tool of some sort, but it almost looks like this cube is skewed a little bit, which would tell me that there's some non-squareness in my gantry system here. Let's see if we can redraw that line because it bugs me. That was X1, I did 150, I think. There we go, that's better. Now, if I put two commands, so all I've been doing are single, you can see them all here. I've just been changing one coordinate. If I change both coordinates, so if I go to X 115 and Y, I think, I don't remember what, oh, let's see, 155. So it's going to go in a straight line from where it currently is over here to X of 115, Y of 155, so it should draw a diagonal across there. Let's see if it does. Oh, but that should have been X 110. So that is a diagonal line, but it's not a diagonal across the corner because that's at 110. I lost track of where I was. But that's okay. Let's see if it can do arcs. Normally slicers don't use arcs. I don't know of any slicer that does, but G-code is not specific to 3D printers. It's more a generic CNC tool. And one of the tools, one of the options in there, instead of drawing a segmented arc, so a bunch of little lines, there are arc commands. I've got to look them up. I think it's G2 and G3, but I've got to check that out and see. Let's see if I can find G-code arc. Yeah, G02 and G03. All right. So the way these work is it takes the point you're at, you give it a new point and a center, and it will draw the arc between those points. So it's you know, the figuring out of how to actually do that is sort of complicated. So I think that's why a lot of slicers don't use them by default. Obviously, you could well, we're about to see if you can actually do G0 commands or not. So let's show you this. No, not that. This. I was looking up the G command. All right, so G02 is, all right, the 02 and 03 are clockwise and counterclockwise, so I've got to see which one is which. Because I want to go counterclockwise. Which one is which? 3 is counterclockwise, so I actually want to 03. So it's the point we're already at, which is, where did we end up? 115, 155. To go to, let's say somewhere over here, which is going to be like, I don't know, 1, or for the X value, it'll be 80. And the Y value will be, let's make it 115, since it's, and then so this is the end point. So the start point is where we currently are. This is the end point, and then you give it a center point. And the center point, let's make at that corner over there, which is X 115, Y 115. That's kind of where we started at. All right, so that's what I'm going to send, and let's see if it even does anything. I don't know if arc commands are built in. No, it doesn't like that. It's either bad parameters, although these parameters are fine. Oh, no, it's not. Because it's not X the second time. It's I and J. I forgot about that. So it's X, Y, and then this one is I, and this one is J, I'm pretty sure. Let me make sure about that. It also has a radius command, too, that we could use. But let's try this. So that recognizing bad parameters is actually a good sign that it might actually work. Nope, that just drew a straight line. So it did draw, and it did draw to the right point, but it did not interpret it as a, I wonder if it doesn't like 0, 3, and it just likes 3. Actually, it won't do anything there. Let's go back to where we were, which is X of, or put some numbers in there. So the only thing I changed here is G3 instead of 03. Nope. Well, no, that is an arc, although it ran off the page. I may have to shut it down. Yep. Oh, it still remembers it. All right. So it is doing an arc, but I guess the place I sent it to made it a really crazy arc. So it doesn't like G03, it likes G3 and G2, I assume. And it did do a counterclockwise arc. So I'd have to get the actual parameters correct, because it did an arc that the center point was way out in the middle of nowhere for some reason. So it can do arcs. That's interesting. That's not a common one that you're going to use very much. Let's raise this up so that it quits dropping ink everywhere. So let's just do a G. Why can I not type on this thing? There we go. G1 X 115 Y 115, but let's also make the Z 10. Oh, it's lost where home is because I turned it off. There we go. All right, so some other commands that you might actually use. The heater commands, those are good to know because there's two sets of them. Obviously, there's one for the bed and one for the hot end, but each one of those has two different sets. And I don't want to send these on because I don't want the bed or the hot end to actually heat up in the current configuration of this printer, but I'll type them in so you can see what they do or see what they look like. So M and you saw these in the G code that we just used because I erased one of them. But M104 is going to turn on the bed heater, and then you give it a set point, maybe 200. And then there are some other parameters, like some hold parameters and things like that. But this is usually the way it appears. What this will do is it will turn the bed on, and it will start heating to 200 degrees. There is a similar command to this that is M140 S200, so same parameters. The difference is the 104 command turns on the heater and immediately goes to the next line of G code, so that it kind of just gives you, if you have a bunch of stuff you're trying to do, it will start the heating process, but it doesn't wait for it to finish. So you don't want to be only using 104. The same commands for the bed are 109 and 190. So you don't want to use the 104 command as the thing that you're going to heat your heater with. It just starts it heating. And then you do some other stuff, maybe home things or whatever, just to try and save a little bit of time. But before you start printing, you want to actually use this 140 command, because it will set the temperature, in this case 200 degrees Celsius, and wait for it to actually get to that temperature before it goes to the next line. So right before you start printing, you do want to make sure that your nozzle is up to print temperature, otherwise it can't extrude filament. So the 140 command actually waits for that to happen. And so you use them. A lot of times you'll see start code that has the 104 command in it just to get things started, and then it does some other things, particularly homing, routines, stuff like that. And then the 140 command following it to actually get up to temperature before it starts printing. And then the same thing, like I said, the bed is 109. You wouldn't set the bed to 200 though. Maybe you set it to 60. That starts the bed heating and carries on with the rest of your G code. And then the 190 command actually gets it all the way up to temperature. The bed one's not as useful because the things that you might be doing that take time is probing the bed, and the bed kind of needs to be heated up for that. So you almost don't use the M109 command that much, just because usually the thing that it's okay to heat the nozzle while you're probing the bed, because the nozzle temperature doesn't really affect the bed probe if you're using a bit like a BL Touch. So that's kind of a time saver is you turn the nozzle heater on and then start probing the bed, assuming the bed is at printing temperature, and you can kind of do both at the same time, heat the nozzle and probe the bed. Other commands you might see, 106. This one also takes a S behind it, a parameter. The numbers, it can go from 0 off to 255 full blast. This is your layer cooling fan. Or, well, it's fan 1. I don't remember the number that it assigns to it. But usually this is your layer cooling fan. Normally you cannot turn off the fan that's cooling the hot end. I know some of you did for one of your assignments, you did the thermal simulation of the hot end with a fan blowing across the heat sink and not with it, and you probably were able to see that if you don't have that fan on, the temperatures in the cold side of the hot end get hot enough to at least begin to melt, maybe not liquefy melt, but exceed the glass transition temperature of your filament, and that's when you get clogs in the hot end, is when that heat sink fan is not on. This is not that fan. This is usually the layer cooling fan. And you can set it to come on. So if I turn this, it'll send the fan on. Now, this fan is up here right now. So it turns that fan on, and then I can slow it down, go about half speed. I don't know if you can really tell that it's going half speed or not. Still pretty fast. Let's go to off. There, you can see that it went off. So that can be useful. Certainly in your G code, it's useful. Using it otherwise is maybe not that useful to do anything with. Let's see. What are some other ones that I use, or at least the one thing I didn't talk about is a lot of the times these G1 commands that you have, we just use them to move the nozzle around, but usually they have something like this. G1, X, 35, Y, 22, 23, I guess. And then they'll have an E value in here. This E is how much filament to extrude while you're making this movement. And it's going to be some fraction, like 1.235 or something. Most of the time, this is the extruder. In fact, this might be useful if we look at, I closed it. Let's get Notepad open so you can see these things. It should still have, no, that's not what I want. Where did that come? Oh, there it is. All right, I don't even know what that is. All right. See all of these E values here? They're cumulative. So the amount of filament to be extruded is the difference in two different lines. So from here, from line 40 to line 39 to line 40, it extruded like 0.03 millimeters of filament. So it's a cumulative thing. And if you look at the very bottom, you can see the total amount of filament that it's expecting to extrude. But see, here's a X and Y command, and these are down to like the thousandths of a millimeter in here. I don't know if it actually resolves that far, but that's what it spits out. And then how much filament to extrude. Sometimes, let's see if I can find one. Sometimes you can see one that has an F after it. I don't think any of these are going to show up in here, though. No, these are just other words. But sometimes you'll have one, and there'll also be a F 3400 or some number. The F is how fast to do this, so it's a feed rate. You can over, actually here it kind of is. So that G1, there's a F 2700, so it's feeding at 2700 millimeters per minute. You do have to know the units on these things. Some things are millimeters per second, some are per minute, some are in like the jerk settings and the acceleration settings. They usually don't show up in the G code though. And then this is actually a retraction, so a E minus 5. So it sucked up the filament so it doesn't ooze everywhere. What else? Let's see if there's any in here that would be useful to point out. Most of these are just going to be drawing. There were some G0s in there I saw. So those are when it's moving. G0 is the faster one, so that's a traveling speed, so it's moving. I didn't notice. It has the feed rate, well, on some of these it has the feed rate out front for specifying fast and slow feeds. Let's see. Well, that's all basically the same stuff. And then there's our encode that we put in there. I think those are probably the major commands that you're going to use. The homing command, this is kind of, we talked about this one when we did the 2-color layer change thing. We did basically the same thing here. M300 is beep, so this only works if you have a sound way to produce sound on the printer. The frequency in hertz, so 440 hertz, and then the amount of the length of the tone in milliseconds. And then this M0 is also a handy one because it lets you pause everything, write a message to the screen if you want to, whatever you put here. You don't put it in quotes or anything, just the next thing is what goes onto the screen. It'll automatically scroll if the message is too long. And then it's waiting for you to press the LCD button to move on to the next thing. The relative and absolute, well, no, G92 is different. So G90, there's G90. absolute, G91 is relative. G92 is interesting, and it can be useful for setting offsets. What it does is wherever the printer's at, so the X, Y, Z, and extruder coordinates, wherever they are, if you just send it G92, that's the new origin for everything. So sometimes that's useful for resetting, like maybe an offset to get it the right height off the bed or things like that. But G92 resets everything, and you can sell it to just reset the extruder. I don't know why it does it twice here, but it does it twice for some reason. Or you could tell it to just reset X, or just Y, or just Z, or just E, or any combination of them. If you don't put any parameters, it resets everything. So that can be useful, but it's also a little bit dangerous in that if you, like in our printer, if we were over here, whoops, let's raise that up. I want to get that in the way. If we're over here and we do G92 with no parameters, this point is now 0, 0, 0, and I could easily, accidentally try to send it to X of 200, which would normally be kind of over in the corner, but now X of 200 is way off the bed somewhere, so you can crash this machine if you're not careful with G92. I think those are the major commands that you might actually use for something. A lot of times you don't, clearly you don't write G code unless that's an assignment to write G code to make a certain pattern. But it's helpful to be able to go look at G code that was generated automatically by Cura and start to figure out what you want to do. Maybe one reason you might write it is if you want a custom start G code that does a certain kind of purge line. Maybe you want the purge line to occur in a spot that it normally doesn't occur, or maybe your slicer doesn't even do a purge line. In fact, I don't think, no, Cura does one. I think it's over here maybe by default. But maybe you don't want the purge line over there, or maybe you want more of a purge line because your filament is really hard to purge for some reason. So you could go and write that in a special code. Like we did with the pen, maybe you want it to wait for you to do something. So you can add those lines in, slice it normally, just go and edit it in a Notepad. Notepad++ is the one that I use, but don't edit it in something like Word because it will add, saving it from Word will a lot of times add extra information into the header that the machine can't interpret. So use something like Notepad or Notepad++ that doesn't add any header information. And don't save it as a text file. Well, let's see. When you do save as, you can, this part can be text, but don't let it put the txt extension on the file name because then it's not G code anymore. Now it's a text file. So erase that .txt that it might add automatically. And make sure that the extension is just .g code so that your printer can read it, or it knows to read it. All right. I think that is enough for today. That's a little G code primer, plotter with your printer if you want to do that. It's interesting. It's more a novelty than valuable. You might find an actual use for it, but it does draw some cool pictures in a way that a regular printer doesn't do it. And you can get really sophisticated with changing out different colors. Maybe that's one reason you want it to pause. You want to do a certain number of lines in one color and then pause, let you change out to a different color. And, oops, you can't see any of that. So one color to another, change them out. You can use that M0 command to change out colors or do different things like that. A lot of different reasons you might want to do some of this plotting. It might be more just a fun thing versus actually valuable though. All right. I'm going to leave it there. I will drop over to Zoom in case anybody has any questions about last minute things. Hopefully next week we'll get the palette. It's kind of back there. Yeah, there it is. Hopefully we'll get it running. It's not running correctly right now, so it sort of works, but not the way I want it to. hopefully that's what we'll look at next week, just as a option of things you might be interested in if you're interested in multicolor printing. It's one way to do it. This one particular one takes 4 colors, combines them into one stream that a regular printer can use to print multicolor parts. All right, I will be back hopefully on Tuesday, and hopefully with the palette working. But right now I'm going to go over to Zoom.